wanted to share that some things I noticed about the lesson that you conducted over sound waves. And the kids were really involved. And for the most part, they knew what they were doing, and when they didn't, they asked you, which is a good sign that they were in tune to what they were expected to do. So if you could, just for our purposes here, tell me what was the objective of the lesson?
Well, they're coming to the point where we're preparing and or getting ready for evaluation. And so the first one of the objectives on my side is to determine how prepared they are to give them an assessment that accounts for whether they've learned it or not. So that's the first thing. The learning objective that is there is for them to be able to manipulate and model Doppler shift situations. So within physics here, they have to be able to model it using the equation. They have to be able to manipulate that equation to find the different variables or constraints. So that's their side, what they are required to be able to do. We're at the point of evaluation, so they need to be able to articulate what they know and what they don't know.
Okay. What part of the lesson were you most pleased with?
I suppose what I like the most is that, that they can engage quickly, that they can say, okay, this is what I understand about this, this, and this. This is what I don't understand about this, this, and this. So that we can start to do the things that can guide them towards the objective, which is to be able to master this particular concept.
All right. And what concerns do you have after conducting this lesson?
It's the same concern I run into because of the makeup of this particular class. They are not all in the same mathematical position, so many of them master it and it's no problem, but then there's a few that are just their math, not their physics understanding, but their math experience slows them down a bit. And so to get them moving through this particular topic and saying that they're all ready, it's a little tricky. I usually use about an 80% criteria. If 80% get it, then we're kind of ready for evaluation. I think we're close, but I think we might be at like 75. Unfortunately, I'll probably find out tomorrow when I evaluate. And then we just go back, and those that didn't do well, they'll go back and work at it again. So.
Okay. Do you have any artifacts that you'd like to share that helped you come to that conclusion?
Well, this is part of some of the students are required to turn, well, they're all required to turn this in by the assessment, which is tomorrow. This will amount to about half of their grade. And on the assessment, what they had to do here was they had to compose problems that pretty much mimic the kind of problems I'm doing and very similar to the problems that they'll have to solve on test day. Now, the thing about it is the ones that are done early are more likely to be the ones that know what they're doing. So, in fact, there's a really high correlation for that. So, they're probably not representative on determining whether it's time to test or not. But, to rewind a bit, they have already had a quiz that they did relatively well. The problem is that there was a gap in between that quiz, and then they had like 4 days where they were gone for stuff. And so I'm a little worried that they might be a little rusty. The whole objective here is to catch them understanding this, not to catch them not. Okay, and that's where I think some teachers have a different philosophy. But my philosophy is I want to be able to give them the check mark on that box. And so I'm a little bit afraid that we might run into some kids that were gone recently because of this choir trip that may not do as well. So we shall see.
Well, what I hear you saying is that you have formative data, though, that led you to believe that most of them were capable of doing this. Can they retake the assessment?
They always can.
Okay.
No.
All right. So you're using this to plan and drive and, in a way, formatively assess.
Well, I use it in several different ways. Some kids don't perform as well on tests as they do on assignments. Some kids, when you give just generic assignments like problems that I have up there, they're just going to copy back and forth, right? So they have to write their own problems here and solve them for themselves, and they may be using those as a template, but they are required in this case, they're not going to get the same answers as their neighbor, because if they are, that doesn't make any sense. They haven't done it. So it's kind of, it's a quasi way to get them to take almost like a take-home test, but it's not entirely. The whole idea here is to keep them kind of honest in terms of what they're doing. The reason that they write their own problems is because if they understand the components of the problem and can identify those components, they're going to do much better on any calculation that they're given. And so they need to look at what's the key. And you can see it, I saw it in a few students where they're misidentifying what they need to know, and it becomes pretty obvious. So, but these particular examples that I have here, the other aspect about this is that when they do these problems, they're supposed to show all work. So I'm trying to also train them on what you do to solve a problem. We're really de-emphasizing answer and more emphasizing technique and approach. So, but these are all pretty good examples because, of course, they got done early. So those students that get done early tend to, it's kind of like when you give extra credit.
Sure.
It's always the kid that doesn't need the extra credit, so anyway.
How did you differentiate instruction to get to this point?
Well, what we tend to do is I encourage the students to take the mathematically more difficult problems for themselves as opposed to the ones that have a little bit more difficulty in math, because the math levels are highly variant. Sometimes some of them are in geometry and some of them are in calculus. It's that far apart. So one of the things that we do is I always present opportunities to take it to a higher level, which some of them do, surprisingly. But I also present the information at a conceptual level. We already took the conceptual part of the test. So like the diagrams and the explanations there. So I try to get that differentiated that way. But this particular thing right here is probably harder for those that are in geometry and stuff. And that's part of the reason why I decided that they could do at least part of this in the take home. Because even though I have kind of two minds about equations, that we know that from data that's been collected in physics that students do better if they have the equations memorized, regardless of all of the things that are said about Google Facts and all that stuff. They just do better. And so I push that, but at the same token, I understand the argument about Google Facts. I understand that, and so I want to try to strike a balance here, and that's what this kind of assignment does.
Okay. What are some other ways that you are going to assess your students on this, aside from the collaborative piece and the problems that they did today? Will this show up later on in the year? What builds on it?
In my course, I abolished units entirely. There are no units in my course because you can be expected to do, like they're doing distance equals velocity times time, which is something that starts at the beginning of the year. They are doing the velocity of sound is equal to the base velocity plus the slope, which is, it has to do with mathematical modeling, the slope of the line to determine what the predicted velocity will be. So the equation is 331 plus 0.5 times degrees Celsius. So, and they have to know where those pieces come from. And that's the key thing anymore in my classes. It's not just equations and numbers. It's like, where do they come from? What do they represent? And that's much more important because it makes it easier for them to remember it. And it also makes them realize that these are related to mathematical principles that they've already learned.
Okay. What will the results on this assessment mean in your next steps?
For me in instruction, it lets me know what I might have to revisit and what I can do next, as opposed to, so because I'm the only physics teacher, I do not feel that I have target X that I have to get to. I feel more like I need to make sure that they have a solid base in being able to model physical phenomenon, to be able to describe in a written way, okay, and to be able to like diagram as well. So they need to be kind of a graphical way of presenting things, and an analytical way of presenting things, and then a narrative way. I can always never figure out the right word for that, but narrative. So they need to be able to make a diagram of some type, to give me a mathematical model equation, and then to give me words. That's what we were trying to do.
Okay. Is there anything you would do differently with a similar lesson?
Yeah, sometimes we do a version of this called the personal practice problem. So we had this in pairs this time because then they bounce ideas back and forth between them. But when they do personal practice problems, it's very similar to this, but they only do it their own problem. What they do there is that's to produce an artifact for their physics portfolio, and so they will either write it on a table or whatever, and then take a picture of it. And that shows at least that they experienced this particular problem and analyzed it. I find that my scenarios sometimes get a little boring, and it allows them to kind of incorporate their own ideas. It also allows them to utilize some of their own modalities that they are interested in. They're allowed to look these things up so that they can, find different scenarios, because mine are always the same stuff. So.
Okay. What has this brought to mind in terms of your personal professional development goal?
Well, my personal professional development goal has to do with formative assessment and implementing different formative assessment techniques. It's embedded formative assessment, which essentially means that it's purposeful and designed specifically for a particular learning outcome. This particular learning outcome is for the students to be able to assess their own knowledge, knowing what they know and what they don't, and if they can construct problems and scenarios that demonstrate that. So that's the particular thing here.
Okay. And what particular Iowa teaching standard were you aiming for with this lesson, or do you want to work toward as a result of having conducted this lesson?
Well, there's a couple of them that are there. One of them stated that the teacher knows content. Now, I hope I know the content, but what I guess I'm trying to do here is to demonstrate content within context. And there's a couple of other ones that have to do with managing.
That's standard 3.
Yeah, and then there's managing the learning environment, and I find that this kind of way to do it helps manage the learning environment a little bit better. I find that when you look at the teacher, if you're aware of those, you can apply a lot of different ones. So to me, those are the two main ones. And then the teacher knows how to assess the learner. To me, I hope that this addresses that.
Okay. I thought the kids were incredibly engaged. Most of them, and I saw, were almost finished if they weren't already finished. And they did utilize each other as well as ask you questions. One girl said, I don't understand how to something. And the girl in her group goes, he just explained, and then she repeated exactly what you'd said. And then they did eventually get stuck, though, and ask for your help. So they were very engaged in the lesson. So if you could just sign this here for me, and we'll put down that you have your post-observation done, and then I will follow up with you before the end of the year, and we'll see how that applies to your professional development goals. Thank you.